Good morning. We're going to look at equivalent fractions today and then also decimals with equivalent fractions. So it says here that use the bars to show and name two fractions that are equivalent to 8/12. So right now, whenever you're asked to show a picture with fractions, you want to somehow show how you can separate out that number. So this is 8 parts out of 12. And then I'm going to think of something that could be equivalent to 8/12. And if I think about 6 with the denominator and have that equivalent to 8/12, I know that 2 goes into 12 6 times, and I know that 2 goes into 8 4 times. So I'm going to make this equivalent here. I'm going to get a text box, and I'm going to put 4, 6. So now I need to represent 4, 6 in this box. So I'm going to use my drawing tool, and I'm going to separate this box out into 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then I'm going to color in 4 parts of that because it's 4 out of 6. So when you show your work today, you can just color in just like this. You don't have to fill it in if you don't want to. And then I know that I can have a denominator of 3 to be equivalent with 8/12 because I know that 4 goes into 12 3 times, and I know that 4 goes into 8 2 times. So 2/12 or 2/3 is also equal to 8/12. I'm going to put 2 there, and I'm going to show 2/3 by my drawing tool. I'm going to separate it because my denominator is 3, so I'm going to separate this whole rectangle out into 3 parts. My numerator is 2, so I'm going to color in 2 out of 3. Okay, and now I'm going to go down to here, and it says how many 6 are equal to 4/12. Write an equation to show this. So I would write 4/12 here, 4 and 12. And I know that if I think about 2 goes into 4 2 times, and 2 goes into 12 6 times, I can have 4/12 equal to 2 6. Now that can also be 2 6. Here, I'm going to do 2 6. 2 6 can be reduced to 1/3 because 2 goes into 2 1 time and 2 goes into 6 3 times. So you can reduce it to its lowest common term, which would be 1/3. Okay, now it says shade in this bar to show 2/5. So I've got 2 out of 5. So I would just shade in my bars here, 1, and 2, because that's 2 parts out of 5. Use this bar to show and name a fraction that is equivalent to 2/5. So if I'm going up now, I know 2/5 can't be reduced anymore, but I know if I multiply 2 times 2 to get 4, I can multiply 5 times 2 to get 10. So if I'm going the opposite way for equivalent fractions, I can multiply my numerator and denominator. So now I know that 2/5 is equal to 4/10. And I can show that by separating out the 4s. Now I have to make sure if I'm separating my rectangle, it's not in 4 parts. If my denominator is 10, I have to separate this out into 10 parts. So I'm going to try to do that equally. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then I'm going to color in 4 of those parts. 4 out of 10, 2, 3, 4. Now it says which fraction is greater, 8/12 or 2/5, and how do you know? So I could draw out a picture to see what it would be. So I've got 8/12. So if I look up here, 8/12 here, and then I'm trying to think, is 2/5 bigger? So I'm going to look at what I have for my 2/5. These rectangles are the same. same distance, 8/12 here, 2/5 here. I know that 8/12 goes further in my rectangle, so it has more parts, so I know that 8/12 is greater. 8/12 is greater. Now I'm going to show you something with decimals here, and we're going to look at a decimal number line. So I've got 1/10, 10 over 100. Then I go to 2/10, 20 over 100. My next number on this number line would be 0.3 or 3/10. And I don't know why that always does that. I'm going to go like that. Or I can also write this as 0.30 as well. Whoops, this is not working very well. So there's 0.3. Well, I'm just going to get rid of that. Not sure why that is going like that. So I'm just going to get rid of this. Sometimes the Cami app doesn't quite work for us. So here I'm going to put 0.3, and then underneath I'm going to put 0.30 because that is saying the same thing. They're equivalent, okay? And then for my fractions over here, a fraction that I would have as equivalent to 0.3 would be 3/10, and then a fraction for 0.30 would be 30 over 100. So if you're doing a number line on Cami, you can, or fraction on Cami, you can use this AB there, and it should take you there. So I can do 3 over 10, and then I could also do 3 over 100. Okay, that would be my equivalent fraction. Then I keep going up, and I have 0.4 or 0.40. And again, this could be 4/10 or 40 over 100. So I'm going to do this here, and this time I'm just going to do 40 over 100 so you can kind of see the equivalence. And I keep going, 0.5, 0.50, 0.6, 6/10, 7/10, and I just keep going, 8/10 until I get to 9/10, okay? When numbers share a place on the number line, that means they are equivalent. For each number, circle the other numbers that are equivalent. So I've got 0.7, which is also equivalent to 0.70, which is also can be 7/10. It can also be 70 hundredths. Now for 9/10, same thing. I get it. It would not be 0.09 because that would be 9 hundredths. So 9/10 would look like this, or 0.90, or 90 over 100, not 9 hundredths. 40 hundredths would be 0.4 or 4/10 or 0.04. Now, when I'm writing these on a hundredths grid, if I have 8/10, that's basically telling me that I have 8/6 of 10. So I have to draw this all the way to 8, and I'll have 2 10s left over on my number line here. And so the equivalent decimal would be 0.8. 0.8 is more correct, and then 0.80. Okay, and then for 3/10, I would just color in 3 lines of 10. 1, 2, 3. And then this would be for my equivalent decimal, it would be 0.3 or 0.30. Okay, so that's kind of equivalent fractions and decimals. We're going to play an equivalent fraction game today in our class meeting, and you have a math page to do from the homework connection actually page for your work today. I'll see you at our meeting at 10:30.